Day 108 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. You know how we do. We're just getting started. I don't see any signs of slowing down anytime soon, y'all. We already made it to day 108, and we're still going. So I hope y'all are still motivated and still continuing to stay consistent and disciplined as we continue on our LeetCode journey, because we have a long way to go. But before we get started, y'all, don't forget. Don't forget, bring your mouse right over here and click that subscribe button for me, y'all. Then after you click that subscribe button, go ahead and smash that like button for me, y'all. Then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need y'all to drop that bank emoji in the comment section so we can run up this engagement and we can help get this content out to a broader audience, so we can do our part in helping to build the Swift community and get this content pushed out, which will hopefully in turn get more people interested in learning more about the Swift programming language, y'all. So now that we got that out the way, I know why y'all are here. And today we have question number 1863, sum of all subset exclusive OR totals. The difficulty level is easy, so you already know how we do, y'all. We're going to keep the solution as simple and easy to understand as well, because we're all trying to learn here, and there's no point in writing code that nobody understands. So let's get into the question and see what the question says. It says the XOR total of an array is defined as the bitwise exclusive OR of all its elements, or 0 if the array is empty. For example, the exclusive OR total of the array 2, 5, and 6 is 2 XOR 5 XOR 6, which is equal to 1. Given an array nums, return the sum of all exclusive OR totals for every subset of nums. Note, subsets with the same element should be counted multiple times. An array A is a subset of an array B if A can be obtained from B by deleting some, possibly 0 elements from of B. So before we get into the examples, let's break down what the exclusive OR operator means when we're dealing with binaries and bits. So I suggest you guys Google the bitwise truth table so you guys can see for yourselves and look at all the different operators that you can use when dealing with binaries and when dealing with bits, which is in turn dealing with binary. So it's called the bitwise truth table. Look it up. There's different operators we could use. Right now we're dealing with this one, which is the exclusive OR, but they also have ANDs or just a regular OR. There's a few others, so check it out, the bitwise truth table. It'll give you all that good stuff about the different operators. But right now we're dealing with this one right here, the exclusive OR. And what this does is when it compares the two bits, it's going to, so say we have 1 in binary, right? And we have 2 in binary. So that's going to represent 1. This is going to represent 2, right? So this is 1 in binary. This is 2 in binary. And we are using this operator. We're using this operator right here, the exclusive OR, right? So what this is going to look like on the output, right? So when we compare these two, since this is a 0 and this is a 0, it would be a 0 right here because they're the same, right? So we put we put a 0 right here. Boom. Since this is 0 and this is 1, we will put a 1 right here. Boom. And because they're different. Since this is a 0 and this is 1 and they're different, the output would be a 1 right here. And then we do the same thing. Since this is a 1 and this is a 0, because they're different, we put a 1 right here. Now, let's switch it up, and so I could give you a better example, whereas say we were comparing 1 and 3, right? So say this is 1, this is 3 in binary. So if we did it like this, we would change this to a 0 because these two are the same. So if this is then since this is 0 and this is 0, those two are the same. So we put a 0 right here. If this is 0 and this is 1, since those two are different, we put a 1 right here. Since this is 1 and this is 1, those are the same, so it'd be a 0. So when they're both the same, like this, we put a 0, and like this, we put a 0 right here. And when they're different, like this right here, like the one in the middle, we put a 1 right here. And that's how this operation works right here, the exclusive OR. So now that we know what this exclusive OR does, let's get into the examples to make it make sense. So we have example 1, we have the input nums 1 and 3, an array of integers 1 and 3, the output is 6. So let's go over how they got 6, and it's not that difficult at all, y'all, once you understand what's going on. So the 4 subsets of 1, 3 are, so the empty subset of x or 0, XOR of total of 0 will be 0 because it's empty, right? So then we have 1. It's a 1 because it's 1. Then we have 3, the XOR has an XOR total. 3 has an XOR total of 3 because it's just 3. Now 1, 3 has an XOR total of 1 XOR 3 equals 2, right? So let's break that part down. So if it's just 1, it's going to be, if it's just 1, it's just going to be 001. So we don't have to compare it to anything, so it's going to stay 001. So let's just put that equal to 1 right here, right? Then we have 3. 3 has an XOR total of 3 because we're not comparing it to anything, and 3 looks like this, so it'd be, 3 looks like this, so let's just say that equals 3, right? We're dealing with this part of the example right here, or it does. We're about to first. Let's go in order. So this, we're dealing with this part of the example is right here. Boom, that's just equal to 1. Then when we deal with this part of the example 3, boom, that's equal to 3 right there. Now let's deal with this part of the example. So this part of the example, we're comparing these two with the XOR operator, right? So that what that's going to look like is, so we're going to have 001 for 1. Then we're going to come down, we're going to have 011 for 3. But we're going to compare them using the XOR operator. And what that's, remember what I said, when they're the same, it's going to come out as a 0, right? So, so that's going to be a 0. Then these right here are different. Boom, that's a 0, that's a 1. So it's going to come out as a 1. Then we'll come over here. Boom, boom. These are the same again. So that's going to come out as a 0. And this is 2. This represents 2 in binary, right? So that's why it says 1, 3 has an XOR total of 1 exclusive OR 3 equals 2. And this is how we got the 2 right here. This right here is how we got this 2 right here. Because when we compare them using the exclusive OR operator, we get 0, 0. They're the same, so we get a 0. We get 0, 1. They're different, so that's a 1. Then we have 1, 1. They're the same, so that's a 0. And this right here represents 2 in binary. So let's just put this over here and say equal to 2, right? Then, so, and that's when we add all these together, 1 plus 3 equals 4, plus 2 equals 6. So let's come in. 1 plus 3 plus 2 equals 6. And that's how we got our output of 6, y'all, for the example 1. Just like that. We just using those two elements, nums 1 and 3. So let's look at example 2. Example 2 is a little longer, so I'm not going to go all the way through it, but I'm going to give you a basic example of what I mean and how it works, right? So let's delete this right here. Boom. Now we're at example 2, right? Now we're at example 2. So first we have a 5. So 5 is going to be equal to 5. Then we're going to have a 1. 1 is going to be equal to 1. Then we have a 6. 6 is going to be equal to 6 because with these we're not comparing anything. So it's going to stay what it is because we're not comparing anything, right? So let's start with this first one just because that's what where they actually compare something so we can make it make sense, right? So let's see. First thing we would do is we would have so what would 5 equal? 5 would equal, in binary, this would be 5, boom. Then we have so we're doing 5 and 1, so it'd be 5. Then right here it'd be 1, so it'd be 1. When you compare these two using the OR, it goes 0, 0. Those are different, so we put a 1. Boom, boom. These right here are the same, so we put a 0. Then these right here are the same, so we put a 0. And this 100 right here is equal to 4, and that's how they compare these, and that's how they got 4, because 100 equals 4 in binary. And I just want to do that one example so you can see how it makes sense, and y'all could do the other examples on your own if you want to, just so you can really wrap your mind around what's going on and how it really works. So now that we understand what's going on, let's get into the code, y'all. And guess what, y'all? Guess what? Today, we got a one-liner. So we got a one-liner today. The code is not that difficult. You know how we do. We love our one-liners. So let's get into it. Let's get into the code and see how it comes out, how it turns out. So first thing we're going to do, we're going to say return nums dot reduce. Reduce, then we're going to open up the array brackets, put int. So we're going to take nums, we're basically going to reduce it into a blank array for now, or we're going to start it off with a blank array, but we're not done yet. Then we're going to say, open up our brackets, we're going to say this going to represent this blank array that we just started. Then we're going to say I, comma, E. Then we're going to say n a plus a plus a dot map. Then we're going to open up the brackets again. We're going to say $0. Now remember, this $0 represents each element in the array that we're working with. And in this case, then we're going to say the exclusive OR operator E. This E represents each element in the array that we're given in num. So this E is going to represent each element that we're dealing with. Then we're just going to come outside that, and we are going to say plus, open up the array brackets, E. Then we're going to come outside those brackets, and we're going to say dot reduce, open up the parentheses, 0, comma, plus, y'all. And that's going to add all of the outputs together at the end. So each time we go through this, it's going to basically create an array right here with these outputs. In this example, it'd be basically these, but it'd be in an array form. And then at the end, when we reduce them, we're going to reduce them all starting from 0. Basically, that's when we add them all together. So this reduce is when we add in all of these outputs together. That's why we put the reduce, comma, 0, comma, plus at the end. Now, that should be all she wrote, y'all. Let's run and see how it runs. Hopefully it still runs. Hopefully it runs how it's supposed to. It's going kind of slow, so you already know something. Oh, and it's still accepted, y'all. I thought something was about to mess up. So let's submit it. Hopefully it stays submitted. Let's see, y'all. Fingers crossed. I don't know what's going on. My computer's going slow, I guess. And it's accepted, y'all. There it is. 6 milliseconds beats 52% of users with Swift, y'all. So there it is, day 108 of doing a LeetCode problem every day. We work with some bits today. So this for all my bit people out there. Hope to see y'all tomorrow for another day, another LeetCode problem. Peace.